Today we're going to take a look at percent problems, and percent problems can be difficult no matter what level that you're at looking at percentages, and you could solve percent problems with a lot of different methods. So let's just take it. Let's just dive into it. Let's just take a look at the first one. It says the number 15 is what percent of 60? So the method I always look at first, just remind students whenever I am teaching this concept of percent equations, is the equation is over of equals percent over 100. This isn't like a super unique, unknown type of scenario. This just allows us to take information out of a statement, like the number 15 is what percent of 60, and to put it into a proportion. You could obviously solve with using solving equations also. You could just set this up using solving equations. So I'll set it up both ways just to show like the thought process, and then you can kind of decide how you want to go about solving it. It says, so I'm going to do the first one as the is, or the first part. I'm going to set my first part of it here as is over of equals percent over 100. So it says the number 15 is, that's going to be my is part of the proportion. What percent of 60, what percent? The percentage is the unknown. So I'm going to put an X where there's a percent. Percent over 100. The percentage is the unknown over 100. And then it says of 60. So is over of. So 15 is what percentage of 60. So the 60 goes there. And then from here, it's just solving a proportion. Now, what if you didn't want to do that? What if you wanted to just set up an equation? You could also do that. It says 15 is, the word is always means equals. What percent? We do not know the percentage of 60. If I'm taking a certain percentage of something, I'm multiplying that percentage by the value. If I want 50% of 100, I would do 100 times 50%, 0.5. Same concept here. So it would be 15 equals 60x. And then you just solve by dividing by 60. You get x equals 15 divided by 60 is 0.25. Now the question says what percent? We get x equals 0.25, so that would be 25%. I want to just show you this solving here, this proportion. 15 times 100 would be 1500 equals 60x divided by 60. And we get an x value of 25. Now notice the differences in our answers. This one we got a decimal value, and this one we got a like x equals something. Just know what you're doing. You know that you set up a proportion where this proportion was in percentage. This x value was a percentage, the unknown, so that's going to be 25%. And then this one we just set up an equation where my x value just came out to be 0.25, so therefore I have to convert it to a percentage. Number 2, the number 30 is 40% of what number? So the number 30 is 40%, so I'm going to convert that to a decimal of what number? So 40% of what number? Now you don't have to do that. You could set up a proportion. I'm going to just show you the proportion. I'll just solve the equation, but I'm just going to set up the proportion. So 30 is 40% of what number? So my of is the unknown, and then 40 is just going to be rewritten as 40, not 0.4, because I'm using a proportion, so I leave it as 40 over 100, because that 40 over 100 takes care of that for me. And then I'm going to go back to the equation now and just solve by dividing by 0.4. I get x equals 30 divided by 0.4 is 75. There it is. So number 3, solving discount and markup problems. A store is having a sale where all items are 25% off. If the original price of a jacket is $80, what is the sale price? So this is a real life scenario. You go into a store, you have some sort of sale amount or some sort of coupon, and you want to know how much is this going to cost me. You make these calculations. You start to figure it out. Like you might guess, if you have a 25% off, like that's not the hardest guess to make, but you might take like 50% and then chop that in half, or try to create increments of 10. You might try to make this a guessing game. But it says a store is having a sale where all items are 25% off. The original price of a jacket is $80. What is the sale price? So we want to know what is 25% of 80. So if I just set up a proportion, I can just solve it that way. And you could also just say, well, if I want to take off 25% off of 80, so I'm asking what is 25% off of 80. So either way, we're just going to get 100x here. 80 times 25 is 2,000. divided by 100. X equals 20. Now that's 20, so let's just finish this up because I wanted to show you both approaches here. You get 20 for both of them. It says, what is the sale price? 20 is not the sale price. 20 is the price of taking 25% off, because 25% of 80 is this $20. So I'm taking $20 off, so the sale price is actually going to be 80 minus the 25% off, which would be 80 minus 20, which would be 60. So the sale price is actually $60. So there is that extra step of making sure you identify, what are we actually asking? What's the question actually asking? What are we actually solving for? Number 4, a smartphone was originally priced at $800. During a sale, the price was reduced to $640. What is the percent decrease in the price of the smartphone? All right, so this problem is a little bit more involved, because we have a smartphone originally priced at $800. During a sale, it was reduced to $640. So what we did is we had a $800 phone, and we took off some percentage. And we got to $640. So we had the original price, and then we subtracted off the percentage of 800, right? Because if it was like, let's say 50% off, I would take 800 minus 50% of 800, and then that will give me my sale price, or the reduced price. What if it was 25% off? I have an 800 price, I take off 25%, or whatever I just said, 25% of 800, and then I'd get my total price. Just like how we did here. We did, in this last problem, we did the sale price minus 25% of 80 to get that $60. Same concept, but it's a little bit more involved because we have to solve an equation now. So now we're solving an equation. So I'm going to subtract 800. I get negative 800x equals 640 minus 800 is negative 160. So then I have negative 160 divided by 800 is 0.2. And that's negative over negative, so that's going to be a positive. So it's 0.2. What does that translate? That is 20% off of the price. And calculate that real fast. Just do. Well, 20%, let's see if that makes sense. 800 times 0.2 is 160. 800 minus 160 comes out to be 640. That checks out. Easy way to check your work there. Now, number 5. A population of a small town increased from 8,000 to 10,000 over the past year. What is the percent increase in the population? This was a little bit different because we're going from an amount to another amount. So we're saying we're starting here, we're ending here. And we have to figure out what is that percent increase. So it's really kind of the same strategy, but you could do it a couple different ways. And I want to show you there's 2 different ways that you could go about solving even number 4 and number 5. But let me just stay consistent. I want to show you just number 5 the same way I set up this one. So we're going from 8,000 people, and then we are increasing the population by a certain percentage to get 10,000. So we want to know, well, if I'm at 8,000, what percentage of that is going to get me to 10,000? So 8,000 plus 50% of 8,000, or 25% of 8,000, or 20% of 8,000 is going to get me 10,000 people. Now, if I backtrack to number 4 real quick, I could have also done a different strategy where I could have said, well, 800 minus 640 was 160. And then I could have taken that amount and figured out what percentage of 800 that 160 is. So I'd say 160 is what percentage of 800. So 160 is what percentage of 800. And then I'd solve that proportion. Same exact thing. You kind of already did it when you went through and solved this, but they're just creating more steps. So I'm just going to say starting point of the population plus 8,000 times a certain percentage is equal to 10,000. So then we subtract 8,000. we get 8,000x equals 2,000. I think I just put 20,000. Yes, I did. Divide by 8,000. X equals 2,000 divided by 8,000 is 0.25. So the increase was a 25% increase. So we could rewrite that as 25%. The difficulty with these last two problems are usually the steps. Going from step to step to step. That's why I like to try to generate just a general equation. So in that way you could see the process just as one single equation and you solve. Like I said, though, on this last one, you could do the same thing here. You can figure out, well, what's the difference between 800 and 640? That's 160. Set up a proportion. Same thing here. You could have gotten the difference between 8,000 and 10,000. That's 2,000. Set up a proportion and say 2,000 is what percentage of the original 8,000. Like you could set that up too and solve. Last one for this chunk of the lesson here. It says find the original price of a car if after a 20% decrease in its value it was $20,000. So now we have an original price we want to figure out. So we have a price. This is the original price. It decreased by 20%. So we went from a price, let's say 10,000. Yes, that's a bad example because now it's valued at 20,000. Let's say $100,000, whatever. It's a $100,000 car, and we decreased it by 20%, and then now it's worth $20,000. So whatever it was, original price minus 20%. So my original price minus 20% of that original price, and it is now $20,000. So what we're trying to figure out is what is that original price? What is X? Same strategy as what we said here. If I have 8,000 people and I add on a certain percentage of that 8,000 people, I now get to 10,000. So if I'm at a price and I take off 20% of that price, I am now at 20,000. So we're doing 1x minus 0.2x. 1 minus 0.2 is 0.8x equals 20,000. X equals 20,000 divided by 0.8. That is 25,000. So that means that the original price of the car was a $25,000 car. We took off 20% to get it down to $20,000.